Hello my dear students, I am Divyam and I am welcoming you all in another video. In this video we are going to have a look on the chapter S block elements, and we will discuss some of the important questions from this chapter. As you can see here, I had written the group 1 elements and group 2 elements. These two groups are included in the S block elements. So let's start with the questions from this chapter. So the very first question is why the group 1 and group 2 elements is known as S block elements. So answer is very clear that the S block element is named like this because if we see the electronic configuration of group 1 and group 2 elements, you can see here this is the electronic configuration of group 1 element. You can see the last electron is filled in the s orbital, lithium. So let's move on to the next question. Why sodium is less reactive than potassium? Or the question can be asked like this, that why reactivity increases as we move down the group? Why reactivity increases? So the question is saying when we move from top to bottom, like from lithium to francium or beryllium to radium, why the reactivity increases? So we all know one trend of ionization enthalpy. Ionization enthalpy is that when we move down the group, the ionization enthalpy also what decreases, because the size increases as we move down the group. So the outermost electron, here you can see the electronic configuration. This electron, this s orbital electron in lithium is filled in the second shell, but in cesium the electron filled in the sixth shell. So as we move down the group, size increases, and this outermost electron is more far apart from the nucleus, or you can say the center. So this electron is loosely bounded and we need very less energy to remove this outer electron. That's why the energy required to remove this outermost electron is very less. That is also known as ionization enthalpy. So as we move down the group, size increases, ionization enthalpy decreases, so the electron can easily take part in any reaction. That's why when we move down the group, the reactivity of the element increases. Why we observe color in flame of some elements of group 1 and group 2. Now the question is, so this color is because of the excitation of the outermost electron, which is filled in the valence shell. When you see, again, electronic configuration is very important. You need to learn also and understand also. So the reason behind the color observation is that when we put this metal in the flame, or when we radiate energy on the element, this outermost electron get excited and move, or you can say the jump on the next orbital. So what happens with this excitation? When the electron excites from its orbital, so it absorbs some amount of the energy which we are giving it. But after that, what happened? It again, this is the excited state, this is the ground state. After some time, the electron again move from its excited state to the ground state by releasing some amount of energy. I think I'm clear what I'm saying here, that this electron absorbs some amount of energy and excited to the next level. But after that, what happens, because there is no any reaction, so the electron is not taking part in any reaction. But yes, if you are giving some energy, the electron absorb the energy and get excited and jump to the next level. But what happened, after some time, the electron releases some amount of energy and come back to its ground state. So the story is behind this an amount of energy. This amount of energy lies in the visible region, and this energy we can see. So this amount of energy absorption is different for different elements. Like lithium absorbs some different wavelength of energy, it releases some different wavelength. Same as sodium releases some different wavelength. So the color changes with the difference in wavelength. That's why we see lithium as a crimson red, sodium as yellow, cesium as blue. Same happened with the group 2 element also. Same as the electron absorbs some amount of energy, get excited, and then after releasing the visible region wavelength energy, it comes down to the ground state, and then we see different types of colors. Why does the solubility of alkaline earth metal carbonates and sulfate in water decreases down the group? One more question related to the solubility is that the why does solubility of alkaline earth metal hydroxide in water increases down the group, and sulfate and carbonates decreases down the group? So let's understand this question first, that this question is also given in your NCERT as in-text question 10.4. The reason behind this, first of all, you have to understand that solubility depends on two things: lattice energy and hydration energy. What are the two main important factor is that lattice energy and hydration enthalpy. So lattice and hydration affects the solubility factor, and we had already studied that hydration enthalpy decreases down the group, right? Decreases down the group, hydration enthalpy. If we compare the metal ions, so hydration enthalpy decreases down the group. But here we have to compare metal hydroxides. So if we compare the hydroxides of the metal, you need to understand that size down the group increases, right? Size down the group increases. So if the size increases down the group, it means the cations are increasing down the group. What I'm trying to say is that metal hydroxide means if I make LiOH, NaOH, KOH, and so on, what is going to happen, that OH is of same size, but the size of cation is now going to increase. As the size of cation increases down the group, lattice enthalpy decreases, and if the lattice enthalpy decreases, we can say hydration enthalpy increases. And because hydration enthalpy is increasing, the solubility also increases. So the all the game is of this size of cation here. Okay, because the hydroxide is the same and hydroxide is a small OH ion. Now if we understand the second question, which was carbonates and sulfates, why they decreases, why the solubility of these decreases, or MgCO3 and so on. So these, the size of the carbonate is very large, very large. All right, so due to the large size of carbonates and sulfates, the cation size is comparable to that. What I'm trying to say is that the size of anion is much larger as compared to cation. So the lattice enthalpy will remain almost constant. So now we will see the hydration enthalpy. If one factor is almost constant, which is lattice enthalpy, so we will move on to the next factor which is affecting solubility, is that hydration enthalpy. So we know that the hydration enthalpy down the group what decreases, hydration enthalpy. As the size increases, the hydration enthalpy decreases. So if the enthalpy decrease, the solubility will also decrease down the group. Alkali metal react with water, explain with example. So you need to understand that if this question is asked, you have to write the reaction also. So any alkali metal if react with water, let's say let's say a metal which react with water, so they form what? They form OH and hydroxide ion and hydrogen molecule. They react like this. Okay, if we take here to any alkali metal, so they release hydrogen gas, hydroxide ion with metal ion. All right, now the next question is that about the reaction of group 1 with the oxygen. You need to keep in mind one thing, that there is a variation shown by the group 1 elements like and rest of the elements. The rest of the elements means potassium, rubidium and cesium. Francium is radioactive element, so we study the science of this element in the radioactivity chapter. We consider only 5 elements in the group 1: lithium, sodium, potassium, rubidium, cesium, when it is about the physical property, chemical property. So the potassium, rubidium and cesium forms superoxides. Okay, and the reaction is given in your Ncert. When lithium react with oxygen, they form MO2. So you have to learn the reaction, understand this is oxide, this is peroxide and this is superoxide. The oxidation state is different in this with the reaction of oxygen. This is very important reaction, very important reaction. You need to learn it. Okay, now the next question is that this is also asked many a times, that why the first element of each group show anomalous behavior. The first element means I am asking about beryllium and lithium, because these two are the first element of the group 1 and group 2. So the reason behind is only one is the very prime reason, is that the size of lithium and beryllium is very small, because this is the first element of the group 1 and beryllium is the first element of the group 2, and both have the size very small. That's why they show anomalous behavior. Anomalous behavior means they have some different types of properties. So the reasons are what? The reasons are small size, high ionization enthalpy, and high hydration enthalpy, and also high electronegativity. Okay, so these are the reasons that why they show anomalous behavior. Anomalous means some different type of behavior which other elements of the same group is not showing. Okay, and the last question is that what do you mean by diagonal relationship? Give example. So the diagonal relationship is that if you see the elements here, and if I make this is a kind of diagonal I am making in the square, right? So when it is this has been observed that lithium shows many a property which magnesium is also showing. And if we say beryllium, so beryllium will show the diagonal relationship with the aluminium. So lithium shows diagonal relationship with magnesium, and beryllium shows with aluminium. Aluminium have approximately similar size. This is the prime reason, and also there are list of the properties which are same. You need to read from your NCERT and you will understand very easily. So here I will finish off my chapter. It's a quick revision. It's the important some examples. I had just given you some questions, some examples, and these questions are very, very important. And as you know, in the term 2 of for this year, lots of portion is deleted from this chapter, and this chapter is very concise, and everything start with the electronic configuration. And it's my tip that you need to understand and learn the electronic configuration first, and you can now with this way you can understand the hydration enthalpy, ionization enthalpy, solubility, and everything. So